Alright, starting with number 7 here, we are thinking about coterminal angles. So if you don't remember what that means, co reminds you of with, terminal, you think end, and coterminal angles share the same end side. So for example, in the first one, it's 2 pi over 3, excuse me, 2 pi over 3. So 2 pi over 3, that's going to be over here, correct? So here's my angle that is 2 pi over 3. So an angle that is coterminal with 2 pi over 3 shares the same end or terminal side that I outlined in blue. So if you think about it, we can just add 360 and we'll always be at that same terminal side. So the idea here is just adding or subtracting the period. So since I'm in radians for this first one, I would add 2 pi instead of 360. So adding 2 pi, okay, well after 2 pi, what's the next multiple of 2 pi? That would be 4 pi. And then if I wanted to get 4, I might subtract 2 pi, oops, I forgot my denominator, and subtract 4 pi. So this is really all coming from the idea that when I add or subtract 360 or add or subtract 2 pi to an angle, it does not change that angle. I'm at the same terminal side. So let's add these together here to review common denominators. So this would be 2 pi plus 6 pi. So that would be 8 pi over 3. This is going to be 12 pi plus 2 pi. So that would be 14 pi over 3. Forgot the one. This would be 2 minus 6. 2 minus 6 would give me negative 4 pi over 3. And last but not least here, I would get 2 minus 12. 2 minus 12 would give me negative 10. So those are your 4 answers. Now, when I was doing this problem with some of you in class, some of you didn't like all of this jazz here. So if you wanted to convert that into degrees, that would be another way of thinking about it. Because it's just a little bit easier, obviously. And part B here, if I'm just adding 360, and then what would be the next multiple of 360? 720, right? And then 225 minus 360, 225 minus 720. So my degree signs. So usually students like that process just a little bit better. Your answers here would be 585. This would be 945, negative 135, and negative 495. Awesome. So that would be for part B. I'm kind of ramming into part C here. Let's move that down here. So this is in radians, so I'm adding 2 pi, adding 4 pi, minusing 2 pi, minusing 4 pi. And I could keep going, right? The next multiple would be 6 pi, 8 pi, all of the multiples of 2 pi. So this first one, if you don't like adding fractions, what you can do here is put in your calculator 1/2 plus 2, and then do the math frac button, and it will give you 5 over 2, and then you just have to add in the pi at the end. Because if you put the pi into your calculator, it won't make it a fraction, because pi is irrational. This next one though, let's see, pi over 2, I'll do this the common denominator way. So this would be times 2 times 2. So that would be 8 plus 1. This is going to be 9 pi over 2. Pi over 2 minus 2 pi, that's going to be negative 3 pi over 2. Right, 1/2 minus 2. And then last but not least here, this would be 1 pi minus 9, negative 8 pi over 2. If you did that with degrees, you would get 450, 810, negative 270, and negative 630. Awesome. Last here, again, just adding multiples. Right? And for this, I get 288, 648, negative 432, and negative 792. So those are all my answers there. For this crazy problem, now it looks like a lot of work, but the idea here is just, again, we're adding and subtracting multiples of our period. So if we're in radians, that would be 2 pi. If we're in degrees, that's going to be 360. Let's move along here. Finding an angle in standard position. So standard position just means that I'm on the origin, right? So I'm starting at the origin 0, 0. And then I'm going out 7 units, and I'm just going to kind of say that that's 7 units here. And then I'm going down 2 units. So building my triangle, kind of making that point 7, negative 2 right there. And now I'm trying to solve for the angle, correct? Find an angle. So this is our angle that we're trying to find. And it would be tangent of this angle would equal opposite over adjacent. So if I'm trying to figure out what that angle is, I would just do the inverse, the tan inverse. Now, in here, it does not say what I want my answer in, radians or degrees, so it's really up to you. I'm going to do degrees because it's a little bit easier for me to conceptualize, and maybe you as well. So I got about negative 16 degrees, which makes sense, right? We know that a negative angle goes this way, and this looks just about negative 16 degrees. That looks reasonable, doesn't it? I think so. If you do it in radians, I think you get like negative 0.3 or something like that, radians. Just for sake of space, I'm going to jump over here. So 10, comma 5, so that's 10, we'll go up 5. So this is 10. And this is 5, right? I'm just guesstimating that point, 10, 5 there. And again, I'm solving for this angle with the x-axis. So this would be tangent of that angle equals opposite over adjacent. So I would be doing the tan inverse of 1/2. And this should be kind of a familiar angle for us, right? Oh, no, never mind. This is tangent. We don't know when the tangent is 1/2. For a second, I was thinking it was a cosine or a sine. So if you do tan inverse of 1/2, you get about 26.6 degrees. Just put that in your calculator. I'm in degree mode. If you want to do this in radian mode, that is totally fine. You'll get a little bit different. You'll get a very different answer, but that's fine because the problem does not say which, so you get to pick. I'll do the last one here, part E, just for sake of space. So this is the point 40. So I'm going out 4 and I'm not going up or down any. So what angle is this? Oh, this is just 0 degrees or 0 radians, right? I'm not going anywhere. I will sneak in part D because it's a little tricky. 0, negative 5 is going to be down here. Again, we're in standard position. So that would be starting from here. All right, so then, sorry about that, I had a little visitor. But this would be 0, negative 5 would be down here. So what angle would that be? Well, in standard position, that's going to be 3 pi over 2 or 270 degrees, right? So I'll give both answers here. So 3 pi over 2 or 270. I guess you also could write this, if I went the other way around, I could write it as negative pi over 2 or negative 90 degrees. So those are 4 options for part D here. This is all for part D. Awesome. Give the coordinates of the point on a unit circle at each angle are great. So I'm not going to spend too much time on this because these should be easy gimme points, right? Hopefully, as long as you have your unit circle out in front of you, these should be pretty simple. Let me track down my unit circle. Okay, so pi over 6, this is literally all you're doing. Look up pi over 6 on your unit circle, and it's just root 3 over 2, 1/2, right? So that one's done. I'm going to jump ahead to this one, part C, because I can see people getting this one wrong. So 2 pi over 3. Well, typically 2 pi over 3 gets me here. So this is a positive 2 pi over 3. A negative 2 pi over 3 is the same distance, but it's in reverse. I'm going the other way around. So where that really gets me is 4 pi over 3. And so the coordinate there would be a negative 1/2, negative root 3 over 2. So the important thing to remember about a negative angle is that I go the other way around my unit circle. So let's do another one here. Negative 3 pi over 2. Okay, well, a positive 3 pi over 2, positive would get me here, correct? That would be a positive. So the negative is the same distance around, but I go in reverse. So that really gets me up here, and that would be 0, 1. And then last but not least, 11 pi over 6, that's again just a gimme, right? Just look that up on your unit circle, and I get this coordinate. So the only tricky part about these is if it's a negative angle, you just have to make sure you go the other way around your unit circle. All right, similar stuff here, right? I'm going to jump ahead to this. Instead of looking at 3 pi over 4, remember, we're going the opposite way. So that really gets me down here. And it's negative 3 pi over 4. So this would really get me at 5 pi over 4. And the coordinates at 5 pi over 4 are negative root 2 over 2 and then negative root 2 over 2. Cosine is the x-coordinate, so this would be negative root 2 over 2. Would be my final answer there, right? So I just go to 5 pi over 4 and look for the x-coordinate. So the tangent of 300 degrees, that should be pretty easy. Just look on your unit circle and you'll see it's negative root 3. I want to talk about this last one here. This is a little tricky. So again, negative pi over 3, this is positive pi over 3. Negative pi over 3, I'm just going in reverse this way down here. And that gets me at 5 pi over 3. And at 5 pi over 3, I'm looking for the secant. Okay, well the secant is the reciprocal of cosine, right? 1 over cosine. It's the flip of the cosine. Well, the cosine at 5 pi over 3 is 1/2. What is the reciprocal of 1/2? 2. 2. Awesome.